In Chapter 7, we move into decimals, and if you look at the beginning of your notes, it says any number that is represented using place value and powers of 10 is a decimal. The word decimal comes from the Latin word decim, meaning 10. What is the most common use of decimals? Now, what you'll notice if you teach elementary is decimals are introduced fairly early on, especially in terms of money. Once they get into 4th and 5th grade, that's when they're going to use decimals beyond the use of money, and they'll have to know the place value names. They begin adding and subtracting decimals and so forth. In 4th grade, they're only going to go to the hundredths place, and much like we promote place value of whole numbers, we'll start teaching more and more place values of decimals as they promote up past 4th grade. Since we're talking about decimals and powers of 10, we're going to do a place value chart. It's not the entire place value chart. We're just going to cover some of it, but we're going to talk about it in powers of 10. So here we know is the hundreds place, but that can be described as 10 squared. The tens place 10 to the first, and then 10 to the 0. And as we go past the decimal point, we have the tenths place, and this is 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4, 10 to the negative 5, and 10 to the negative 6. And I want to write this in decimal form, in fraction form, and then even add the place value name here. So we know 10 squared is 100, and so let's go ahead and add that this is the hundreds place. 10 to the first is 10, so we know this is the tens place. 10 to the 0 is 1, and this is the ones place. Then we have 10 to the negative 1. Now 10 to the negative 1 is really 1 over 10, because we know when we have a negative power, we would move that to the denominator. This is going to be decimal point 1. That's going to be the decimal form of it. And as far as words, this is the tenths place. 10 to the negative 2 is going to be 1 over 10 squared, which is basically 1 over 100. If you want to write it that way, it's 1 over 100. That is going to be decimal point 0.01, and this is the hundredths place. 10 to the negative 3 would be 1 over 10 cubed, but I'm going to go ahead and write that as 1 over 1,000. That is decimal point 0.001, and this is the thousandths place. 10 to the negative 4 would be 1 over 10 to the positive 4th, which would make that 1 over 10,000. And that's why this is called, well, the decimal form of it would be decimal point 0.0001, and this is the 10 thousandths place. 10 to the negative 5 would be 1 over 10 to the positive 5, and so that would be 1 over 100,000. Decimal point would be 0.0001, and that's why this is called the hundred thousandths place. And the last one we will discuss, even though we know place value doesn't stop here, but the last one we're going to discuss is 10 to the negative 6. That would really be the same as 1 over 10 to the positive 6th. What that would end up being, 10 to the 6th, is a million, and so it would be 1 over 1 million. Decimal version of that would be decimal point 0.00001. So once you're in that position, this is now a million. And so just wanted to have that in your notes. I know you could find that online or in your textbook as well, but it's a good reference for you to have. What I see a lot as far as walking into an elementary or junior high classroom is I see teachers, and say for example we have the number 3.42. Teachers will just say 3.42, and when you do that you're really not emphasizing and teaching that place value. So if it was really the number 3.42, what you should say as the teacher is that's 3 and 42 thousandths. And we'll talk about that as we move on. The next thing we have is a note here. When reading a decimal number, you say the place value of the last digit. So like on number 1, 5 is the last digit. Number 2, 8 is the last digit. Number 3, 2 is the last digit. Whatever that last digit is, it names that decimal number. And so like I was saying on number 1, I really would not want you to say that's 32.005, because when you're just saying that point, you're not teaching the names of the place value. I wouldn't allow your students to say that either. Now I know we're all comfortable with the point, but when we do that, it's going to be harder for our students to remember the place value names. And so on number 1, I think about the 5. The 5 is going to name the number. The place value that 5 is in the thousandth spot. So that number is 32, and that decimal point is named by the word and. So it's 32 and 5 thousandths. And so we're going to practice reading these. We're going to write them in expanded place value form as well as in word form. So writing it first in word form, this is going to be the number 32 and 5 thousandths. And remember that last digit is going to name the entire decimal number. Now as far as doing it in expanded form, this is going to be expanded notation. We start teaching that in early elementary, and then that grows as the place value that they're learning grows as well. The 30 is in the tens place, so this is going to be 3 times 10 to the first, plus the 2 is in the ones place, so that's 2 times 10 to the 0. The 5 is in the thousandths place, so that's 5 times 10 to the negative 3. And that is the expanded place value form of that number. On number 2, we're going to name this number by the last digit, so that 8 is going to name it, and you have to decide what place value that's in. So if we count out, that's 1, 2, 3, 4, 5 places after the decimal. So if you look up at your chart above, you can see 5 places after the decimal is the 100 thousandths place. And so when we say this, we actually say 10,458 hundred thousandths. And I get a lot of students in college that have a hard time naming that number, but it's because that place value wasn't emphasized to them when they were learning that in late elementary and junior high. So I'm going to consider this number right here, which is 10,458, but it lands in the 100 thousandths place. So it will be 10,458 100 thousandths. And then we're also going to write that in its expanded place value form. So you go through and you do that with each digit. So the first digit I have is the 1, and it's in the tenths place. So that 1 is going to be 1 times 10 to the negative 1, because it's in the tenths place. The next one will be the 4. The 4 is in the thousandths place, so it would be 4 plus 4 times 10 to the negative 3. Then I have the 5, so it's plus 5 times 10 to the negative 4. And then the last one would be plus 8 times 10 to the negative 5. So there's the word and expanded form for number 2. On number 3, we have a whole number 6, and then that's followed by the decimal. Remember, we're going to name it by this last digit 2, so if we count, that's 4 places after the decimal point, so we can see 4 places from the chart above is the 10,000th spot. So when I write this in words, this is going to be 6 and. Anytime you see the decimal point, you're going to use the word and. So it's 6 and 392. And remember, we said it's in the 10,000th spot. So 6 and 392, 10,000ths. Now, as far as writing that in expanded form, that's going to be 6 times 10 to the 0 in the ones place. Then the 3 is in the hundredths place. So that's 3 times 10 to the negative 2. The 9 would be 9 times 10 to the negative 3. That's in the thousandth spot. And then the plus 2 times 10 to the negative 4, that would be in the 10,000th spot. The next thing that we look at is talking about how we could use base 10 blocks to represent decimals. We start using base 10 blocks as early as kindergarten and first grade. We know that when we have 10 ones, cubes, that can be replaced by a long, which represents a 10. When we get 10 of those longs, we can trade that in for a flat, which represents 100. Those can also work well when teaching the addition and subtraction of decimals. So it says, in a set of base 10 blocks, let one flat represent one unit. Now the thing about it is, when we use our base 10 blocks, we have a cube, a flat, we have a block, a flat, a block, a long, a flat, and a cube. And so really there's only 4 different variations of those base 10 blocks. We definitely have more place values than 4. And so what I want to remind you, and you might want to write this down for yourself, that small block, whatever, and this is just the 1, this is what usually represents the 1 for us, that small block will always be the smallest place value. So for this particular problem, it says, in a set of base 10 blocks, let one flat represent one unit. And so one flat is representing one unit. That tells me that this flat right here represents the ones place. What I can tell from that then is that the long is going to go down one place value. So that long would have to be a 10th, because if you go up on the page to your chart, 1 smaller than the ones place would be a 10th. And so when it tells me a flat is a unit, a ones place, that tells me that a long has to represent a 10th. The next one, part B, what would that cube represent? Here is that cube, that smallest block. That cube would be 1 smaller than that, which would be a 100th. And so here we can finally do part C, where we're going to represent the number 1 and 23/100ths using that block representation. So this is going to be a flat decimal point, 2 longs, and then 3 of those small cubes. And so definitely those base 10 blocks are really good manipulatives for you to use even when you're teaching decimals. Make sure though, if you are doing this, that you keep this in mind. That small cube will always be representing the smallest place value that you're working with. Okay, on the next page, we're just going to kind of go backwards. I'm going to give it to you in word form, and we're going to write the numeral that goes with it. So 2/100ths means that there's a 2 in the hundredths place. The hundredths place is 2 places after the decimal, and so the numeral form of this would be 0.02. The 0 in front of the decimal, some teachers require it, some teachers don't. It's really a place value holder. That's going to be up to you when you teach that. I think it's always good to have that. It holds that place value and it helps the students line them up better when they begin adding, subtracting, multiplying, etc. Number 2, 4 and 2800 thousandths. That word "and" means that decimal point. So we have 4 and 2800 thousandths. So that 8 has to land in the hundredths thousandths. So what I personally do is I think to myself, okay, I have a tenth, a hundredth, a thousandth, a 10,000th, a 100,000th, and that's where that 8's going to land. It was actually 28, and then I would fill the rest in with zeros. So that's 4.00028 in word form. That's 4 and 2800 thousandths. On the next one, I'm giving you the expanded notation, and I want us to write this as the decimal numerals. So we have 5 times 10 to the third. That's 5 times 1,000. 2 times 10 squared, that'd be 2 times 100. And then 4 times 10 to the negative 1, that's going to be 4 times a tenth. What you can do, if it helps you, is you might change it to this first. That's 5 times 1,000 plus 2 times 100 plus 4 times a tenth. And so if you do that, it might help you get that set up for the numeral form. So when I write this number now, we have 5,200, no tens, no ones, but we do have 4 tenths. On the next one, we have 4 times 10 to the negative 3. Plus 2 times 10 to the fourth. This is going to bother some people because it's not written in descending order. You might have some students rewrite that in descending order. But when I think about this, I think, hey, this is 4 times 1,000th. 10 to the negative 3 is 1,000th. Plus 2 times 10 to the fourth, that's 2 times 10,000. So when I think about this, what I have is I have 20,000 and 4,000. So that's decimal point 004. Next, we have a definition of a terminating decimal. A terminating decimal is a decimal with finite number of places to the right of the decimal point, a decimal that ends. There are going to be decimals that we come across in this unit that go on infinitely. We know that we have sometimes 2/3, and in decimal form 2/3 is the 0.66666, and that goes on infinitely. Finite means that we have a decimal that terminates. So 0.5 or 5/10 is a terminating decimal. What we're going to talk about is taking a terminating decimal to a fraction, and I've given you a two-step process. Number 1, place the decimal number in the numerator. Number 2, place the value of the last digit would indicate the denominator. So for example, number 1 is a tenth. A tenth means put this number over 10. And so right here, place the value number in the numerator. So the value of the number is 1. Its place value is a tenth, so it's 1 over 10. And that's the same as the decimal 0.1. Number 2, we have 2,902. That's going to be the numerator as explained in the instructions. In the bottom, we will put the place value. So here we have tenths, hundredths, thousandths, 10,000ths. So it's going to be over 10,000. Whereas number 1 could not be simplified, number 2 can be reduced. And basically, you can just divide both of those numbers by 2. And when you do that, you get 1,451 over 5,000, and that's the simplified version of that fraction. And that fraction is the exact same value as the original decimal. The next one, we have negative 44 and 12 hundredths. Now the 44 is a whole number, and so I'm not going to mess with that. That doesn't need to be changed into a fraction because it's a whole number. What we'll be changing into the fraction here is this 12 hundredths. So the 12 hundredths is going to be 12 over 100. We can divide both of those by 4 to reduce that. And so what that reduces to is 3 over 25. So I write this number as negative 44 and 3/25. And we can do that anytime we have a terminating decimal. That's the two-step process that you'll go through. Next we have a theorem. Theorem 7.1 says a rational number a over b in simplest form can be written as a terminating decimal if and only if the prime factorization of the decimal contains no primes other than 2 or 5, which can be written as terminating decimals. So first one, we have 7/8. Now if you read that theorem again, the theorem is talking about the prime factorization of the denominator, and it can only contain 2s or 5s. So I don't worry about prime factoring this first numerator because 7 is a prime number. If I prime factor 8, that's going to break down, if you do a factor tree, into 2 times 2 times 2. The prime factorization of the denominator only has 2. So the theorem says a rational number in its simplest form can be written as a terminating decimal if and only if the prime factorization of the denominator contains no primes other than 2 or 5. This contains no primes other than 2 or 5, so I will say that this can be written as a terminating decimal. On number 2, we have 11 is a prime number, so that can't be prime factored. If we do a factor tree for 250, I could start with saying that's 25 times 10. The 25 would be 5 times 5. The 10 would be 2 times 5. And we see all of these prime factors in the denominators are 2s or 5s. So this can also be written as a terminating decimal. On the third one we have 21 is not prime, so I go ahead and to reduce this I'm going to say, okay, 21 is really 3 times 7. 28 is 4 times 7, so that would be 2 times 2 times 7. And you can cancel those 7s because basically it wasn't reduced. It wasn't in its simplest form, and so that's why we need to reduce it first before we test for this theorem. Now that it's reduced, my denominator only contains 2s, and so this can also be written as a terminating decimal. Let me just add one for you to show you one that can't. Let's say we have 19 over 75. 19 is a prime, so I'll just rewrite that. 75 would be 3 times 25, so that's 3 times 5 times 5. That 3 does not cancel, and so when I prime factor the denominator in its simplest form, it contains another number other than 2 or 5, and therefore this one cannot be written as a terminating decimal. All right, last example, it says write the decimals from greatest to least. I will kind of give you some advice if you have this on your homework or quizzes or exams. If the negatives are throwing you off, what you can do is you can remove those negatives, put them in order from greatest to least, and know that when you add those negatives back, it's going to completely reverse the order, because we know that a large negative number is really smaller than a small negative number. And so that's something you can do if you're struggling with this. The greatest number here would actually be the smallest, because of the negatives, it's going to be that smallest value. And so here, when I look at this, I have 4 numbers. The greatest number here would be -2 and 504 thousandths. Going in order, the next one I would have is -2, 5,164 ten thousandths. Going down to least, my next one would be -2 and 56 hundredths. And then the smallest number I have here in this 4 numbers is -2, 564 thousandths. All right, just a couple little things to show you as far as this. In the face-to-face class, I do bring in coupons to show, and I just wanted to show you. This is a really good thing to show your students. Here's just a coupon I found online. I have a lot of them in a baggie that I take into the face-to-face class. But what you notice is it says save 35 hundredths of a cent. This is actually a question that I put on the test, and I say, okay, what's wrong with this? If you had a student write this on a piece of paper, how would you explain to them the problem with this? Now, we know as far as money, you don't need that decimal point and the cent sign. What that actually says is it's 35 hundredths of a cent. That's less than 1 penny. It either needs to be 35 with the cent sign or decimal point 35 without the cent sign. And so you'll be able to find these. A couple of weeks ago I was driving and I saw a sign at CVS and it says Kleenexes, and it had the decimal point, and they were 99 cents a box, but it had decimal point 99 cents, and so that's actually less than 1 penny. So just show these to your students, explain the problem with this, and tell them if they ever do see this, you can go in and get a really good deal on whatever you're purchasing. Another activity I like to do when we do decimals is, this is really great to do when you're trying to start teaching decimals and teaching this vocabulary, this decimal of the day, and you can do a different decimal number every day of the week. You can have the standard form, the word form, the expanded form, writing it with exponents. You can have them do some rounding here. These bottom rules are excellent, increasing it by powers of 10 times 100 times 1,000, dividing by powers of 10 where they're just moving that decimal point from left to right. And then it also has the place value chart here for them. And so really all I did was I saw this online because I'm always looking on Pinterest or just different blogs for teachers, and I like it. And so all I did was type in decimal of the day. This PDF came up for free, and so you can print it and you can pick your decimal of the day and have your students write it in several different forms.